Solving simultaneous equations when you have a linear and a quadratic equation. So basically what we're doing here is just solving systems of equations where they're not both linear equations. So the easiest way to do that is to basically use substitution. So I'm going to get the second equation equal to y by adding x to both sides. So then I have y equals x squared minus 5x plus 7, and y equals x plus 2. So now they're both set equal to y, so I can set them equal to each other. So when I set them equal to each other, I just have x squared minus 5x plus 7 equals x plus 2. Now I just need to solve this quadratic equation. We will talk more about solving quadratic equations later, but right now we're going to be able to just factor. Okay, so I'm going to start by subtracting x and subtracting 2, and that's going to give me x squared minus 6x plus 5 equals 0. And then I factor right here. And when I factor, this should go back to what you did last year a little bit. When I factor, we have x and x. They need to multiply together to get 5, add together to get negative 6. So that's negative 1, negative 5. And if you want to verify, you can FOIL that back out to make sure that works. And you will find that it does work. So now I need to solve this. Well, if I set this one equal to 0, and if I set this one equal to 0, then I would have a true equation. So that's what I'm going to do. I'm going to set x minus 1 equals 0, and I'm going to set x minus 5 equals 0. You need to do both parts. Okay, add the 1, x equals 1. And add the 5, and we have x equals 5. But we're not done yet. All we've done is find x. X could be 1, or x could be 5. Now we have to find out what our y would be for each one. So I'm going to pick one of the equations. I'm going to pick the easier one. Y minus x equals 2. And I'm going to put in 1. So y minus 1 equals 2. Well, that's going to give me, add the 1, 3. So y equals 3. And if x equals 1, y equals 3. Therefore, 1, 3 is an intersection point. The next one, again, pick that same equation just because it's easiest. Y minus x equals 2. And that would be y minus 5 equals 2. Add the 5 over. Then y equals 7. Therefore, when x is 5, y is 7, that is an intersection point. So we have two answers. That's the key. There are two answers for this problem. 1, 3 and 5, 7. You have to have both of them for it to be correct. This next one is very similar, except they're already both solved for y, so we can jump right to the step where we set them equal to each other, because this is y and this is y. So x squared equals 3x plus 4. Subtract everything over. Minus 3x minus 4. And I get x squared minus 3x minus 4 equals 0. Then I factor. When I factor, I get x and x. Multiply together to get negative 4. Add together to get negative 3. So plus 1 minus 4. Negative 4 plus 1 is negative 3, so we're good. 1 times negative 4 is negative 4, so we're good. And then if we FOIL it back out, we would get that. So always check by FOILing. So I need to set this equal to 0 and the x minus 4 equal to 0. So x plus 1 equals 0. Then subtract the 1. X equals a negative 1. X minus 4 equals 0. Add the 4. X equals 4. So those are my two possibilities. So for x equals negative 1, pick one of the equations and put it in. So if we put it into that first equation, the linear equation, 3x plus 4, put in negative 1, y equals 3 times negative 1 plus 4, y equals negative 3 plus 4, which is 1. So y is 1 when x is negative 1. And we have our other one. Our other equation, we know that x equals 4, so we're going to put it in, equals 3x plus 4. Put in 4 for x, y equals 3 times 4 plus 4, y equals 12 plus 4. 12 plus 4 is 16, thus y equals 16 when x equals 4. So our other possible answer is 4, 16. Those are our two answers of intersection for this equation, this system. That's it for your notes over solving simultaneous equations, linear and quadratic. Go through the practice problems. Make sure that you can do these problems and you can do the factoring parts of these problems to make it simpler for yourself. And then you may take the quiz over this material.